Gonna shoot me down, 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 down. Now I'm because of you.
It's good to see you guys. I haven't seen you in a while. We went on Christmas break, and then I missed the last two chapels. We were in Nicaragua serving, so once you guys get to high school, maybe you have a chance to serve with us in Nicaragua. But I'm excited to be back. I'm excited to see you all. I hope you guys had a great break. Hey, we got a really exciting chapel planned for today. As you guys start getting into high school, you'll have a chance to take some different Bible classes. One of the classes you guys can take is a class called Apologetics. You'll be able to learn, how do I defend the Christian faith? What are some of the arguments against some of these big questions that we have when it comes to God and the world and creation and all of these different things? Some of you guys have already started asking those questions. I'm sure you already have those big questions rolling through your mind of, how can God exist in the world, and how did he create the world, and how do we know that God is real, and all these big questions that we sometimes have, not just as students, but as adults too. We have big questions as well. And so this morning, our chapel speaker is from Toronto, Canada. So they're having a pretty rough winter, and so when I said, hey, do you want to come to South Florida in January, he jumped at that opportunity. But he's really excited to be with you guys. He travels all over the world speaking to students, to adults, training Christians in how to defend the faith, helping us answer those big questions. He's got a really popular YouTube channel, maybe you've come across it, called Red Pen Logic, where he'll interact with popular TikToks and videos of people offering critiques of Christianity, and he'll offer responses and help us think through how do we respond to those big critiques and questions. And so I'm really excited to welcome him. So I want you guys to help me give a big, warm TK welcome to Mr. Tim Barnett.
Thanks. All right, I have a question for you. How many in here like science? Show of hands. Who likes science? All right, cool. Okay, here's another question. How many of you like math? Are you guys booing the math people? Don't boo the math people. Okay, I have a confession to make. I like science and math. In fact, I became a full-time high school science and math teacher. All right? Wow. Very cool. Now, I did that for a number of years. I worked at a school, actually a Christian school for a few years, and I worked in the public system. And then I kind of fell in love with this thing called apologetics, okay? Now, apologetics is not going around saying, I'm so sorry, I'm a Christian, please forgive me. No, we make other people sorry, we're Christians. That's what we do. No, we don't do that either. What we do is we make the case for Christianity. We try to provide arguments and counter-arguments. We try to be persuasive. And so that's what I've been doing with a ministry called Stand to Reason for almost 9 years now, okay? Having a lot of fun doing that. Now, one of the other things that we're doing is during COVID, when I couldn't travel, when they closed the border, I'm a Canadian, they wouldn't let me into your country, and actually they wouldn't let us into churches and all this other stuff that was going on. I couldn't speak and do this work, and so what I started was a YouTube channel, and we called it Red Pen Logic, where we actually took the red pen and actually critiqued and corrected memes and videos and that kind of thing, and it really took off. And so I'm just curious, anyone in here, show of hands, heard of Red Pen Logic? Come on, where are my people at? There's a couple. Okay, so that's going to be your homework assignment, all right? When you leave here, not now, but later, you're going to open up YouTube and or Instagram or wherever you guys are on, if you're on any of those things, and find Red Pen Logic. Here's what I want to talk about this morning, though. I want to talk about how science can actually strengthen your faith in God. Now, I want you guys to give me a chance. Even if you don't like science, I want you to hear me out this morning. In fact, I want to talk about how the heavens declare the glory of God. I want to begin with a story, though, a true story, that takes place April 11th, 1970, at 2:13 p.m. Eastern Standard Time. Who can tell me the significance of that date? Who wants to take a guess? Someone says Star Wars, the font is just to throw you off, okay? It has nothing to do with Star Wars. Sorry. Good guess, though. Gabriel, right? Is it Gabriel? You won the door holder thing, right? Yeah. People love Gabe. Congratulations, by the way. What do you think? Say that again? Space shuttle? Very good. You know what? You are like right there. You are right there. Now, good job. Now, I actually wonder how many people thought that was the year I was born? Anyone? Yeah. I'm going to ask you guys all to leave. I was born in 1983. No, don't leave. 1983, not 1970, okay? Now, this was actually the launch of the Apollo 13 space shuttle from Kennedy Space Center in Florida. This was the third scheduled mission to land on the moon. Now, unfortunately, as many of you may know or may not know, Apollo 13 would never actually land on the moon. You see, initially, everything was going to plan on this magnificently designed spacecraft. However, 55 hours and 54 minutes into the mission, traveling at 2,000 miles per hour, the crew feels and hears an explosion. And then you get pilot Jack Swiggert's famous words, "Houston, we have a problem." And it was a massive problem. In fact, one of their oxygen tanks had exploded, and the other was severely damaged, leaking into space. They now were losing electrical power that controls all the controls of the space shuttle. Apollo 13 had a new mission, and that was to bring these three astronauts home safely. And that they did. 3 days later, despite limited power, loss of cabin heat, a whole bunch of other problems, the Apollo 13 mission, the astronauts were able to come back to Earth safely. This mission was actually called a successful failure. Now, why am I telling you about the Apollo 13 mission? Well, just as those astronauts survived against all odds in the lethal conditions of space, we too survive against all odds on this planet that we call Earth. Very good. You're still with me. The Apollo 13 spacecraft was finely tuned to support life, the life of the astronauts. And the slightest change in those conditions put their lives in danger. In a similar way, the conditions of the Earth, and we'll see the solar system and the galaxy, and actually the structure of the universe, are finely tuned to support life. And the slightest change in these conditions puts life in jeopardy. Now, scientists say that the fine-tuning of the universe is balanced on a razor's edge. And here's how you can think of that. Imagine a tightrope stretched across two skyscrapers, okay? And you're on there with no safety harness. We would say literally on either side, the conditions don't support life, right? Like literally, if you take one step to the left or one step to the right, you plummet to the ground and your death. Only the narrow position on the tightrope allows for life. And in a similar way, what we're going to look at is the Earth, and we'll go up from the Earth and we'll look at our solar system for a second, and then we'll go up from our solar system and we'll look at the galaxy, and then actually we'll go up from the galaxy and we'll look at the universe. We'll see them that those are all finely tuned, just like that. They're balanced on a razor's edge, and we're going to do that in like 18 minutes. How does that sound? Does that sound like fun? 3 of you think that sounds like fun. That's great. That sound good? Okay, excellent. How many of you have heard of Goldilocks and the 3 Bears? Got some Goldilocks fans here? Okay, excellent. You guys know that 1 porridge is 2 what? And 1 is 2? And 1 is just? Just right. Just perfect. Just right. Right? Now, there's actually something in astronomy that we call the Goldilocks principle. And it has to do not with porridge, it has to do with the distance of a planet from its planetary star. We call ours the sun, and it has to do with that just right temperature. So, for example, if we looked at Earth, we zoom in here on Earth for a second, if you were to go further out from the sun, Well, it's going to be too cold, okay? Mars is a little bit further out. Even at its equator in the middle of summer, it's like average temperatures around freezing, okay? It's kind of like Canada. If you were to go a little bit closer to the sun, well, there's Venus, and Venus is really hot. Venus is like 700 degrees Fahrenheit, so you don't want to go there, on your summer vacation. Too hot. But if you've been to Earth, and it is absolutely beautiful this time of year, okay? It is just the right temperature. So too close, too hot, just the right temperature. Now, it's not just that it's just the right temperature. It's just the right temperature for something that life needs, and that is liquid water. Without being just where we need to be, if you were too far out, you might get ice. If you were too close, you might get water vapor. But on Earth, we actually get all three states of water: solid, liquid, and gas. In fact, what you're looking at is a bit of a miracle, okay? It's really fascinating how water has all these cool properties. Man, I wish I had 25 minutes to talk about water, okay? Like, it's a universal solvent. It will dissolve all these minerals that can be sent all around the world. It has a really high specific heat capacity, which means it can take a lot of energy to even raise it a few degrees. That's why when you're on the sand on a hot day, it's like really hot on your feet, but then you step into a puddle and it's nice and cool. Really cool, but what the coolest thing about water is that it's like unlike every other substance known to man. Every other substance that we know of, when it goes from its liquid form to solid form, does it get more dense or less dense? Well, particle theory says it gets more dense when you go from liquid to solid. But because of water's structure, H2O, it actually gets less dense, and it's why that giant ice cube is floating. In fact, if water was like every other substance, lakes and oceans would freeze from the bottom up. And this would create a very difficult problem for life. But I can see that you guys aren't impressed by that. Say, Tim, I'm not impressed by that. Okay, we'll see if we can impress you. Now, Earth, I don't know if you noticed it when you walked in the room, but the Earth is actually tilted. Some of you walked in the gym and were like, whoa. No, you didn't notice it. You didn't feel it. But the Earth is tilted. If it wasn't tilted, then the equator would be even hotter than it is, and the poles would be much, much colder, making life highly improbable. But the Earth is actually tilted at 23.5 degrees, and this allows for the moderate temperatures that we have, even though we do get extreme temperatures at the poles and the equator. But one of the things that's related to that is the moon. Now, if you want life on a planet, you need a large moon. Our planet has a moon that is a quarter the size of the Earth, and it actually stabilizes the Earth's tilt as we travel through space. Again, scientists think that if we had no large moon, there would be no life on our planet. Pretty cool. But I can see you guys aren't impressed by that either. Say, Tim, I'm not impressed by that. Okay, let me see if this impresses you. You guys know that there's a giant bar magnet in the center of the Earth? It's not really it's like a liquid iron core, but it creates a magnetic field. And that magnetic field actually acts as a shield that protects us from cosmic particles coming from the sun. And those particles could annihilate Earth. But we're not actually worried about that because we have this shield that deflects those particles to the poles. In fact, have you guys heard of the Northern Lights? I don't know if you can see the Northern Lights from here. In Canada, you can sometimes see them. It's really cool. That's actually those particles interacting with the gases at the poles, and it puts on this light display. Really, really cool. And scientists think no magnetic field, no life. But I can see you're not impressed by that either. So what I want to do is go to the solar system. We're going to go up from the Earth to the solar system. Now, when I was in school, there were 9 planets. Those were the good old days, right? Those were the good old days. Did you guys hear what happened to Pluto? What happened to Pluto? I think you got the answer. Yeah, so that's good. See, a lot of people... So Pluto got demoted. It's no longer a planet. We call it a dwarf planet. Now, a lot of people think that's because it's too small, and that's actually not the reason. The reason Pluto got demoted from being a kind of full-blown planet has to do with its orbit. Its orbit is actually highly elliptical, so not circular, but elliptical, and crosses over Neptune's orbit. And I don't know who gets to make this call, okay? But if you don't have your own orbit, you can't be a planet, okay? And so Pluto was discovered, I think in the late 90s, got demoted. So let's get rid of Pluto for a second. So we got 8 planets. We have 4 gas giants, those are the big guys, and we have 4 terrestrial planets, those are the ones close up to the sun. Now, what's really cool about this setup is that there's all this space debris, okay, junk that floats around. There's asteroids, this kind of stuff, comets. And if an asteroid were to hit the Earth, like a good-sized asteroid, that would be trouble. That'd be like reset, all of life gone. Now, we're not worried. We're not too worried about an asteroid hitting the Earth, and I'll tell you why. It has to do with these 4 big gas giants, in particular Jupiter. Jupiter is massive, okay? Like, this is not to scale. The red spot on Jupiter is a storm, and it's like 2 times the size of the Earth, okay? That's a big storm. That's a big hurricane. You could fit like 1,300 Earths inside Jupiter. Because Jupiter is so massive, it has this incredible gravitational pull. And that gravitational pull sucks things into it. And oftentimes, the things that, like asteroids that are floating by in our solar system, that we think might come straight for us. Actually, everyone together now. Let's read this together. Oh, no, it's an asteroid. Wow. I got chills. I was a little nervous. Like a little Armageddon situation here, okay? But we're not really worried about it. We're not worried. I'll tell you why. Jupiter is like a cosmic vacuum cleaner, okay? And it actually will suck up, all this kind of stuff that pulls it in. In fact, as Jupiter orbits the Earth, there's like this tail of stuff that kind of follows behind it that gets pulled into its gravitational pull. But let's go out from the solar system. By the way, you should thank God for Jupiter. I was giving this presentation years ago when one of my daughters was really young. She was like 3. She heard me say that. And so for like a year at night, she would pray and thank you, God, for Jupiter. It was really cute. It was adorable, right? But it's true. When I taught from the science textbook in the public school system, it said in our textbook, if Jupiter didn't exist, you wouldn't either. Okay? And that's true. Now, our galaxy is really cool. Actually, where we reside in our galaxy seems to be just right. Not just the right planet, not just the right solar system, but just the right galaxy. You guys know what our galaxy is called? The Milky Way. Now, kind of fun fact, in Canada, we don't have the Milky Way chocolate bar, okay? Just saying. We have something called the Mars bar. Very similar, not the same though, okay? Our galaxy is 100,000 light years across. Now, that's a distance measurement. If you're going to measure something like really big, you want a big meter stick or yardstick. So, we could use yards for this room, but if you want to measure a galaxy, we need a bigger yardstick. So they use a light year. That's the distance that light travels in 1 year, which is 6 trillion miles, okay? It's 100,000 light years across. There's about 100 billion stars. So our star, the sun, is one star amongst 100 billion. There's a black hole in the center that things seem to be kind of orbiting around. It has a disk shape, and it has a spiral shape. And so these arms that you see are just dense clusters of gas and stars. Where we reside, though, seems to be just right. It's kind of like a Goldilocks zone. You don't want to be too close to the center of the galaxy. Lots of big stars blowing up. We call those supernova, and you don't want to be next to a star when it explodes. You also don't want to be too far out in the galaxy, because as you get too far out, there's no heavy elements Think of your periodic table. It's like hydrogen, Chemistry class would be really easy, Helium, just a couple elements. But we need oxygen and carbon and nitrogen and all these other elements for life. Here's the thing. I want you to forget everything I just told you. Forget it all. And you're thinking, already done, right? Already done. Because the fine-tuning that is causing scientists who once were atheists to become Christians, or at least believers in God, has to do with not just the fine-tuning of the earth and the solar system and the galaxy, but the fine-tuning of the whole universe. The fine-tuning of the universe. It seems like there are these constants and quantities that are put in when the universe was created, like the mass of the electron and the mass of the proton and so on, or the up quark and down quark is what we know those are made of, neutrons and protons. That dial is set just right. And if you change the dial, you mess up the universe. You change the universe. And that universe won't allow for life. And so if you go from clicking the dial from life permitting, just go over, it goes to life prohibiting. Like, we will not allow for life. When I was a kid, this is before like iPods, you had to tune a radio. Has anyone ever tuned a radio in here? Where you're trying to find like your favorite station and it's like, and then all of a sudden, you hear NSYNC singing Bye 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 or something, and it comes in clear, but if you go too far, you lose it. That's the kind of fine-tuning. There's possibilities, but there's actually a value that will allow for life. Here's what one scientist says about it. He says, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe, in some sense, must have known we were coming. Like the universe, the more I study, the more it seems like this is set up for us. Or how about Fred Hoyle? This guy went from atheist to believer or theist. He says, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seems to be so overwhelming as to put this conclusion almost beyond question. Here's one more quote. Here's an astronomer. He says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather, and then he puts a capital A, agency, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? The answer is yes. He asked this, was it God who stepped in and so providentially crafted the cosmos for our benefit? The answer is yes. Here's what he's talking about. Here's one example, just one, in my last 4 minutes. One example. It has to do with the gravitational constant. Now, you all know what gravity is. It's what's holding you in your seat right now. Okay? That's what gravity's doing. Every two objects in the universe are gravitationally attracted to each other. I'm attracted to the Earth, that's why I'm not floating away. But I'm also attracted to the Andromeda galaxy 2.5 million light years away. In fact, I actually use this as a pickup line on my wife, but I won't go into that, okay? That's a story for another day, okay? But here's what you need to know. Here's what you need to know. That the gravitational constant is fine-tuned to 1 part in 10 to the 40th power. That is a 1 followed by 40 zeros. That is just to give you a sense, the odds of you being struck by lightning are 1 in a million. The odds of you winning the lottery in Canada are 1 in 100 million. The odds of you being struck by lightning, surviving, and being struck by lightning again in your lifetime are 1 in a trillion. But the odds of getting a life-permitting gravitational constant, 1, 10 to the 40th power, all the zeros, okay? It would be like this. Taking dimes, covering the entire continent of North America in dimes, say that's a lot of dimes. It is. I copied and pasted all those on there. Okay, that's like an afternoon I'll never get back, okay? And then you stack those dimes all the way to the moon. So entire continent of North America to the moon, and then do that on 1 billion more continents. 1 billion more continents. And I take one dime, paint it red, throw it into the sea of dimes on 1 billion continents stacked to the moon, and I blindfold you, put a gun to your head and say, pick the red one or you're dead. That is the one life-permitting dime. If you were to pick the red dime, no one in this room is going to say, well, wow, you're lucky. No, you'd say, you peeked. You could see through the blindfold. You designed the outcome. You would intuitively know that there was design happening. Although somebody might say, well, it could happen, but you end up sounding like Lloyd Christmas from Dumb and Dumber. See, Lloyd travels across the country to declare his love to Mary, and he asks, what are the chances of us being together? Here's what he says. Here's what she says.
What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance? Yeah!
All right, no, 1 in 1,000,000, saying there's no chance. She should have said 1 in 10 to the 40th power. That's what she should have said, right? But that's just one constant, and we could look at all kinds of other constants that are finely tuned. The best explanation of this fine-tuning is design, is a designer. Here's what one astronomer said. I'm almost done here. He says this, for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Because what have theologians been saying for centuries that 20th and 21st century scientists are discovering? The answer is, in the beginning, God created the heavens and the earth. That's what they're discovering in the 21st century. Here's the thing, though. Let's exchange our telescope for a minute and just open up the Bible, and what you find out is there's more to this creator than just that he made everything. It says this, in the beginning was the Word, and the Word was with God, and the Word was God. Verse 3, all things were made through him, and without him was not anything made that was made. And then you jump down in John 1:14, says, and the Word became flesh and dwelt among us. Here we have the creator of the universe, made everything we just looked at, didn't remain distant and detached, but actually came to this earth as a man. Why? For you and for me. Came for you and for me to die on a cross to take your sins and my sins so that I wouldn't have to pay the penalty that I deserve because I have sinned against God. And that's kind of the coolest thing that we could talk about in this entire presentation. Let's pray. Father, we're so grateful for this time where we got to look and study your cosmos, to see what you have done. Your fingerprints are all over this world. Thank you for all this really cool evidence. I pray the students would meditate on this and it would strengthen and bolden their faith as they grow and are discipled and as they share their faith with others. I pray they would ultimately see the Creator, the Son, Jesus Christ, who's come and died for them in their place. I pray that they would trust in him. In your name we pray. Amen.
Amen, amen. Hey, can we thank Tim for sharing with us this morning? It's a miracle that you're here, and so I hope that you guys would reflect on that and know why you're here. If you have big questions and you want to follow up, I'm sure any of your teachers would be happy to do so. Let's end with our benediction. You guys know the drill, and then after the benediction, you guys are going to stay seated, and the teachers will get a little head start. So say it with me. Jesus is for me. At the cross, he and rose again. Thanks be to God. Amen.